Okay, perfect squares and square roots. Squaring a number, just multiply it by itself. So 3 squared, 3 to the second power, 3 times 3, 9. So 1 squared is 1 times 1. We can add in another one, another perfect square. We got 0 squared is just 0, 0 times 0. 2 squared is 4, 3 squared is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. So 8 squared, 8, hold on a second. 8 squared is 8 times 8, which is 64. And 12 squared, 12 times 12. If you've forgotten how that works, this is going to be something where you don't get a calculator. 12 times 12. 2 times 2 is 4. 2 times 10 is 20, so I got 24. And the next row I've got 10 times 2 is 20, and 10 times 10 is 100, so I got 120. And then I added up 4, 4, 1. 12 times 12, 12 squared is 144. What do we call a 12? That's right, it's a dozen. And a dozen is 144. It's called a gross. You might see that on the side of some boxes in, say, Ayers, when there's like a whole bunch. They might say 5 gross, so they have 5 times 144 little toys in there. So square roots go the other way. 3 squared is 9, so the square root of 9 is 3. It's the opposite. The square root of a number is a value that can be multiplied by itself to give the original value. So you're asking, what can I multiply by itself to get this? Using the square root symbol. The square root of 9 equals 3. So the square root of 25. We're thinking 25 is 5 times 5. So the answer to square root of 25 is 5. What is the square root of 36? What times itself is 36? 6 times 6 is 36. The square root of 36 is 6. I do have to say, sometimes you'll see things that say, what is the negative square root of 36? And they're asking, what times itself that's negative will give you 36. This would be negative 6. Because negative 6 times negative 6 is 36. Perfect squares. I should add in 0 here, sorry. Perfect squares are the squares of whole numbers. Starting with 0 and going up. Let's add 16, 17, 18, 19, and 20. If you know these perfect squares quickly, it's easy to go backwards to figure out what's the square root of 36. So 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. It's a good idea to know those first 20. Well, this is really 21 perfect squares. But 0 is an easy one to remember, isn't it? So it's very easy to work out perfect square roots, but it's kind of tricky when you have other numbers. Like, let's say, square root of 10. Square root of 10 is irrational. It's not a perfect square rooted. I can't think of a number that by itself multiplies by itself to get 10. 3 times 3 is 9. 4 times 4 is 16. So the answer is somewhere between 3 and 4. Because 10 is closer to 9, like if I have a number line, I've got 9, 10, 11, oh, sorry. Let's try a real number line. If we look at 9 to 16 on the number line, I have 9, 10, 11, 12, 13, 14, 15, 16. This is much 10 is much closer to 9 than it is to 16. So I would say closer to 3 than it is to 4. So square root of 57. I have to think of a perfect square below 57 and a perfect square above 57. 57 is between 49 and 64. So that means that the square root of 49 is less than the square root of 57, which is less than the square root of 64. So 57's square root is between 7 and 8. Is 57 closer to 49 or is it closer to 64? It's slightly closer to 64, so it's closer to 8 than it is to 7. Square root of 18. Square root of 18 is somewhere, since 18 is between 16 and 25, I can look at the square roots of those numbers. Square root of 18 will be between 4 and 5. 18 is closer to 16 than it is to 25, so this is closer to 4. Square root of 126. 126 is between 121 and 144. So then I'm finding the square root of all of these things. 121 is the same thing as 11 times 11. 144 is 12 times 12. 126 square root is between 11 and 12. Is it closer to 121? Is 126 closer to 121 or 144? That means that this answer, square root of 126, would be closer to 11 than it would be to 12. If you wanted to estimate, you could see if maybe 11.1 works. Square 11.1. Remember, this is a part where you don't have a calculator. You do the 1 times 11.1, and 1 times 11.1, and 1 times 11.1. I get 1, 2, 3, 2, 1. That's a pretty number. Okay, so 123.21 is not quite 126, so maybe a little bit bigger. We could try 11.2 times 11.2. And I get the first row, the second row, and the third row when I multiply. And I add them up. I get 4, 4, 5, 2, 1. Yep, that's pretty close. 11.2 would probably be a pretty good estimate for this square root.